Uh, hey everyone, I'm truly excited to be here today. I'm currently working as a senior software engineer at Oracle, where I'm focusing on building scalable and compliant data systems like that support the global clinical trials. So over the last decade, I have had the opportunity to modernize the insurance platforms for organizations like MetLife and Ivari, like spending a lot of time with mainframes, COBOL, and the deeply intertwined architectures like that have powered these companies for like more than 30 years. So that journey taught me something very important. Like legacy systems are not the enemy, but the way that we maintain the silence is. So the danger comes when a 30-year-old COBOL program like becomes a black box. So when no one truly understands like how it works, like innovation slows, so the data becomes trapped, and organizations lose their competitive advantage because they can't keep pace with today's expectations. So today I'm going to walk you through a real practical blueprint, not the theory, on how to modernize these kind of legacy systems safely and gradually. So specifically, how to evolve them into the cloud native data lake houses without breaking any mission critical operations or disrupting customers or taking unnecessary risks. And coming to the challenge. So the challenge, like let's begin by acknowledging the reality we all face in the insurance world. So these companies are powered by the systems that are literally like older than many of the engineers maintaining them today. And there is a reason like they have lasted this long. So they are they are like unbelievably reliable. So that's the reason that they lasted this long. And they run billions of dollars in transactions every single day, and they contain decades of business knowledge, and knowledge that is difficult to rewrite or either replace or recreate it. So but reliability has a cost, right? So these systems offer almost like no flexibility, and they do not support real-time analytics, or they cost a tremendous amount to maintain. So COBOL expertise is increasingly rare, and because everything is batch driven and nothing can happen instantly. So these systems were built for a world of paper forms, like physical underwriting, overnight jobs, and weekly reporting, maybe. So not the real time digital experience that customers expect today. So think about any modern customer, like they want some instant policy codes, mobile first servicing, and like they also are looking for some real time fraud alerts and digital onboarding, like maybe automated updates and 24/7 availability. So these 1990s mainframes simply cannot do this on its own. So, and when we look inside these systems, like the main thing is a data problem. Like it becomes even bigger. Like the COBOL stores data in formats that don't align with the modern schemas, and the many fields are overloaded with multiple meanings, and like metadata that is provided is non-existent, and the data and logic are also tightly coupled in COBOL programs. So it's so what I meant is like it's almost impossible to extract the reusable data sets from this COBOL programs. So this makes the reporting difficult. Like it makes the modeling like slow or maybe inaccurate as well. So machine learning becomes nearly impossible like with these COBOL programs. So the integration problem is equally challenging. Like when you try to connect these legacy systems to the outside world, every integration like feels like a surgery, I can say. A simple enhancement can take months, or adding one new field might break another system, or APIs behave inconsistently. So like any change of the above mentioned, or any changes introduces a new risk. So the true challenge is not just updating the software, but it is modernizing the data, architecture, and processes, and also the organizational culture, like all at the same time. So that's why the modernization require incremental approach. So now going to um, the insurance platforms. So the insurance platforms, they cannot simply shut down for maintenance or migration. Like they run the entire business, policy issuance, claims processing, billing, and all of this depend on like a continuous system availability. So that means the modernization must happen while the old system stays alive and fully functional. So there are like several mission critical requirements that we had to meet. Like high availability like was non-negotiable. Like there should be a 99.99 percentage uptime, like or better. And the regulatory compliance as well, like it had to be ensured. And also every policy change that had to be fully auditable, like with a clear trial from source to the destination. And also there should be a zero tolerance for the data loss. And all the customer information had to be remain protected and secure during this entire migration journey. So so most importantly, the modernization had to happen with no customer impact, like no disruption to ongoing policies, and no downtime for the core insurance operations that were running every day. And that's why modernization cannot be a big bang, but it must be in a incremental, safe, and transparent. And yeah, the architecture, like when we faced the complexity of this legacy environments, we asked ourselves a critical question, like how can we unify all this data like without replacing the entire system? So the answer was to build a data lakehouse, like an architecture that combines the flexibility of this data lake with the structure and reliability of the data warehouse. So in insurance, this is extremely powerful because it breaks down the silos and creates a single platform like that supports everything from real-time ingestion to the batch analytics to machine learning. So these are the advantages. As Lakehouse solves like several major problems at once. It supports both real time and historical analysis, like the schema enforcement, while allowing the flexibility, and it supports the time travel of the queries, and which are essential for auditing mainly. And it also becomes a central foundation for ML as well, like the tracking and the cross team collaboration. So these are all the main changes that we will be seeing once we use this architecture. And in modernization projects, the lakehouse becomes a new source of truth, but the legacy system continues running uninterrupted. So the lakehouse starts collecting the operational data through CDC, which is nothing but a change data capture, and it then serves the analytics, like it powers the dashboards and hosts machine learning models and delivers the real-time insights back to the business. So the insurance workflows depend heavily on the historical and real-time data. And also, like before the lakehouse, organization often fall into the trap of like numbers not matching across teams. And like claim has, like for example, the finance has one version of truth and claims has another version. So after the lakehouse, everyone sees the same data, so interpreted in the same way, with the shared lineage and governance. So this alone improves the transparency and the trust, and also the decision making across the entire organization. um, Coming to the technology, so a quick walkthrough of the technology that enabled this architecture. So we used Kafka for streaming events and the change data, and Debezium handled the CDC change data capture from mainframe and on-premise databases. And Spring Boot allowed us to build the lightweight decoupled microservices. And Kubernetes orchestrated these services across environments and gave us the auto scaling and rolling deployments. And coming for the computation and storage, like Spark and Delta Lake gave us the high performance pipelines with the and Snowflake and Databricks provided analytics, and also the machine learning environments we utilized. And along with that, we have a requirement of visualization tools like Power BI and Tableau made insights accessible to business stakeholders. So this stack was intentionally designed to be cloud to be into the cloud workflow, so that allowed the organization to modernize at its own pace, like without to go to the one cloud vendor, like, or one ecosystem, that I would say. And coming to the pattern that we used in this modernization. So this is main important thing that I want to emphasize. Like, the modernization projects fail most often, like when a team attempts a big bang rewrite. So it's too risky, like, and it's too expensive and unpredictable as well. So that's why this triangular pattern is something that we used. So think of this approach as maybe a vine which is slowly growing around a tree. Like, instead of cutting down the tree, which would risk everything, like, we grew new systems around the old one, like gradually replacing it bit by bit, or pieces by pieces. So here is how it works. We start by identifying one small, like, independent function inside the legacy system. For example, we started with policy lookup, and payment posting, profile editing. So something with clear boundaries. So we then rebuild that single function as a modern microservice. Like, we redirected the traffic from the legacy system to the new service. If anything goes wrong, like, we can easily roll back because the original function still exists. Over time, as confidence grows, like, the legacy version of that function is retired. So this approach delivers the zero downtime, like, and also offers us the immediate rollback and continuous delivery as well. So it reduced lower risk and built trust across the organization for us. And like, I just want to read note out the practical example. So the first components we modernized were policy lookup, payment posting, and customer profile services. So these weren't most complex components, but they were safest to replace. Like, within a year, almost 60% of all traffic, like, had been shifted from COBOL to this modern microservices. So the teams gained confidence and releases accelerated. So this was the successful example that we can showcase to our business, that we showcased. And the business wins also were enormous. Like, we displayed them, we saw faster delivery cycles and the cleaner architecture as well. And the change that we made is of, like, we maintained it to be a lower cost of change, and reduce the main thing is reduce the dependency on the mainframe systems. So now next is the schema evolution. One of the most challenging parts of modernization is data modeling. Like, the COBOL copybooks are incredibly, like, hard to work with. Uh, like each field has some overloaded meanings. Like, some contain different data types based upon, like, hidden rules, or sometimes the metadata is almost, like, non-existent, and the dates are encoded in strange formats. So these are all, like, and also the business logic. So the business logic is buried inside the procedural code, not stored in the database. So to modernize this data, we go through a structured transformation process. Like, we analyze the copybooks thoroughly, and we identify the overload, the ambiguous fields that we see in that copybooks, and then we build the data models based on that. And often we, like, using the JSON, like, that clearly defines the structure, types, and meaning of each field. So these models form the foundation for our modern schemas in the lakehouse. Then we add the metadata and governance rules. We implement the schema evolution so that the structure can adapt to the new requirements as well, like, without breaking the downstream. So this step is often underestimated, but it is very critical, like, which gives us a clean, well-defined ability, and also the ability to run AI models as well. And also we can extend it to build the fraud detection systems as well. So like, I mean, which in turn gives us the self-service analytics environments. And the policy issuance improvements. So once the modernization began, like the results were immediate and visible as well. So the policy issuance times, like they have a major impact. Like they dropped from almost 5 days to 4 hours. Imagine, like it just previously without modernization it was like taking 5 days in total, and now it came to 4 hours and business was happy. And the real-time validation reduced the errors dramatically, and agents also began receiving instant feedback on any inconsistent information or any missing information. And also underwriting became faster, and also hence the customers also became happier. And the claims processing. So the claim processing timelines also transformed. Like when what once took like 3 weeks, we reduced it to just 2 days. So automated routing eliminated the like manual bottlenecks. So the customers could track the status of their claims transparently, and the fraud patterns were detected early on, like using the AI models that previously weren't possible with the legacy systems. So both the customers and the internal teams felt the difference immediately. And the CDC based synchronization. So now let's talk about one of the most important technical components of this entire journey. So the CDC. Without CDC, the safe modernization is nearly impossible. Like CDC works by monitoring changes in the legacy database. Like it captures, inserts, updates, and deletes in real time. So these changes are streamed into Kafka. So the microservices can subscribe to these specific topics and process only the data they need. So the lakehouse injects the same events which keep it synchronized with the legacy system. So the benefits are massive. There is no need for heavy ETL, no need for any batch windows, no need to pause any systems or any data drips. And this CDC essentially transforms the legacy system from a static data into a real-time publisher, like which we can term it as a rich data. And the multi-layer data quality. So in insurance domain, like as I worked on it, so I could say insurance data must be perfect. A single incorrect date can affect payouts, or a single missing field can invalidate a claim. So this is why data quality assurance must be like automated and layered. So we implemented a 4-layer model, like a raw data, and cleansing the data, curating the data, and the gold data. So each layer had automated validation checks, like verifying missing values, duplicate records, and if any of the data has any invalid formats or any mismatched calculations. Like, these are all were checked in all of this 4-layer model. On of this, like there is this AI driven detection as well, like which detects any flagged suspicious claims or any inconsistent underwriting behavior or any payment patterns like which are unusual. So this multi-layered quality framework reduced the manual QA like by more than 70% and dramatically improved the trust in the data. And the transformational results. So the modernization journey delivered the results across the organization, like the policy issuance, as we discussed before, like as I mentioned, it dropped from 5 days to 4 hours, and the claim processing as well shrank from 3 weeks to 2 days. And the new product launches, anything that came after the modernization, became 40% faster, like because we could like prototype and validate data models instantly. So because of these advantages, it has been increased 40%. And the infrastructure costs as well were reduced by more than 35% through this cloud usage. So organizationally, there was a cultural shift towards a data-driven decision making. Like departments began like collaborating more closely because they were finally working from a trusted data foundation, I would say. And the real-time dashboards empowered with instant insights. Like team no longer debated like whose numbers were correct or everyone like because everyone aligned with the lakehouse. Technically, I would say that a system became future-proof. Like legacy dependency reduced significantly, and new services could be deployed quickly, and also the AI systems could finally become part of daily operations. So this is where modernization proves its value, like not only in cost savings or any performance improvements, but also in its ability to unlock the innovation across the entire company. And the next is the critical success factors that I would discuss. So there were like several key factors that made these transformations possible. Like we started with a small high value domain to build the confidence, and we built trust through continuous validation and verification of legacy versus new data. And we included the business stakeholders in every sprint, like ensuring alignment. We also automated governance, like auditing and checks that we have done, like the regulatory checks. And we prioritized schema clarity over like speed, and documented everything so teams could evolve independently, like without breaking each other works. And the lessons learned. So there were valuable lessons learned along the way. Modernization is more about people than technology, I would say. So the legacy systems hide decades of knowledge. So extract that early, and don't migrate every field, just migrate what is actually used. Always build rollback paths, like in case something fails we can just go back and use the legacy systems, so that way we don't uh, give any disruption to the business workflows that are already existing. And uh, and also like my recommendations that I wanted to give are very simple, like invest in training, and also the tools that we use should be standardized, and create some build cross functional squads like that can move quickly and learn together. uh, Coming to the conclusion, like modernization is not just about replacing any legacy systems, but it is about unlocking the tremendous value like trapped inside. So with the right combination of lake houses, microservices, and the change data capture, schema evolution, organizations can modernize safely, like gradually and like also intelligently. So the journey is long, but the rewards are very exponential. Like yeah, that I would say. And yeah, thank you so much for the time.